Hello my friends and welcome back to the channel. My name is Aladdin. If you're here, it probably means you're fed up with your models breaking or not being able to handle pressure. Today we're going to dive into the two fundamental aspects of 3D printing that will guarantee your models are strong, but also save you massive amounts of time and filament. Let's do it. Don't forget to subscribe and hit the bell icon so you don't miss out. What we're going to do is print the exact same shape 4 times with different parameters. Then at the end of the video, we'll test them to see which one can handle the most pressure, compare filament usage and printing time, and you'll understand everything. So let's start by making one small cube and then clone it 3 times. Okay, regarding the dimensions, I'm going to set them at 30 millimeters by 30 millimeters with a height of 8 millimeters. Okay, after that we select the cube, right-click on it, and select Clone. Set the count to 3 and press Enter. Okay, let's organize them and we'll start setting the parameters for each of the cubes. Okay, before we start, the first thing I want to explain is the primary factors that allow any 3D printed model to withstand pressure and be extremely strong. There are 2 things. First, the wall loops, which are essentially the number of walls the 3D print makes. And second, the sparse infill density, which is basically how much material we are filling our model with, from 0% when it's completely hollow to 100% when it's completely solid. Okay, check this out in the preview to really understand how this works and what these numbers actually mean. Okay, so let's check out the layers in the preview and explain. As you can see here, inside the cube isn't 100% full on the inside, and that's what explains the 15% setting for sparse infill density. Okay, moving on to the wall loops, which is set to a default of 3 here. These are, as we said, the number of walls the 3D printer creates, and it keeps building them layer by layer until the model is finished. All right, now that everything is clear, let's go back and set specific parameters for each cube. Then we'll see how much time each one takes and how much filament it consumes. All right, let's start with the first cube. For this one, I'm going to set the wall loops to 7. And as for the infill density, I'll set it to 0%. All right, and for the second cube, I'm going to set the wall loops to 5 and the infill density to 5%. All right, moving on to the third cube. I'm going to set the wall loops to 3 and the infill density to 15%. And for the last one, I'm going to set the wall loops to 1 and the infill density to 25%. After that, let's head over to the preview to check out the layers. All right, as you can see here, the parameters we set have been applied to each cube. However, we just need to go back and set the top layers and bottom layers to 0 so that after printing, the wall loops and infill will be clearly visible, allowing us to compare which parameter works best. All right, here we set the top shell layers to 0 and the same for the bottom layers as we discussed. Now going back to the preview, we can see that when we print, the infill density and wall loops will be completely visible. All right, everything is ready now. We've set up all the parameters. The only thing left to check is how much filament and time each cube takes, so we can compare them and see which setup works best. So for this reason, I need to create 3 more plates so we can analyze each cube individually. So we click on Add Plate to add 3 more plates, and we place each cube on its own plate. Keep in mind that we won't see a massive difference here since we're dealing with a small test cube, but we'll still analyze the slice data and reach a conclusion. There will be differences, even if subtle, so let me double check. so we're just testing the core principle here. However, with a larger model, those differences will be much more noticeable. As we can see here for the first cube, it consumed 2.98 grams of filament and took 12 minutes and 49 seconds to print. His second cube, it used 2.62 grams, which is less filament than the first one, but took 12 minutes and 58 seconds, so slightly more print time. For the third one, it used 2.68 grams and took 13 minutes and 9 seconds. For the fourth one, it used 2.74 grams and took 13 minutes and 12 seconds, taking the most time, though not the most filament, so we can conclude that increasing the infill mainly affects the printing time, while adding wall loops has a direct impact on the filament weight. All right, now all that's left is to send the cubes to print and check out the results. Let's go! All right, my friends, the cubes have finished printing. Now it's time to test which one is strongest and handles pressure the best. All right, let's start with the first cube, where we set 3 wall loops and 15% infill. As you can see, when I press on its sides, it doesn't offer much resistance, and if I push any harder, it will snap. All right, moving on to the next cube, the one with 5 wall loops and 5% infill. So it's not super solid either. It's better than the first one, even though the first one used more filament. Next, 1 wall loop and 25% infill. I'd say this is a great result. It holds up really well. But I still feel a bit of flex when I press hard on the cube. For the last cube, 7 wall loops and 0% infill. Honest truth, when you first look at it, you might think it won't hold up, but it's actually the strongest one of them all. To conclude from my personal experience, wall loops are much more important than infill density when you need a part that tolerates heavy loads without breaking. You saw earlier how the printing time was lowest with 7 walls and 0% infill. But finding the right balance is key. For example, using 6 walls with 20% infill will give you incredible strength. Personally, I never go above 25% infill on any of my prints. I hope this video helped you master this fundamental 3D printing concept so you can take full control of your print times and filament usage. Don't forget to subscribe, hit the bell icon so you never miss an upload, and I'll see you in the next video.